let's say I gave you two numbers, root root 9, root of 9, and the root of 4, and I asked you to compute these values for me. You're probably already blurting out on your screens that this root of 9 is 3 and the root of 4 is 2. And that's not really hard to acquire. I mean, simple. We just know 3 squared is 9, 2 squared is 4, and I don't need to go into those details. And that's possible. Maybe some of you want to even be more precise, and they're probably telling me that this is plus or minus 3 or plus or minus 2, because negative 3 times negative 3 is positive 9, just as 3 times positive 3 is positive 9. And the same can be said for the root of 4 and plus or minus 2. And we know that these values are easy to compute because we're very aware and very, used to this, to knowing that 3 squared is 9, and we know how to do these values. Work with them, rather. But what happens if I gave you the root of 2, and I told you to compute this value? Well, we're not very familiar with what the root of 2 is because we're not very familiar with the number we square to give us 2. But if we ran to our calculators, we'd probably find a value like 1.414, and on and on and on. Let me close that. And on and on and on. Well, surely this is a lot harder to compute at first, unless you're very good with your square roots, or you've mastered a couple of them and committed them to memory. But we see that working with root 2 is a lot trickier, right? But one thing I want to point out is that root 2 is an irrational number. It's an irrational number. And what does irrational mean? Well, irrational numbers are numbers basically that we cannot express, that cannot be expressed as a fraction, cannot be expressed as a fraction, for example, a over b, in its simplest form. And so, if we have an irrational number, well, a rational number would simply be the complete opposite. A rational number is a number that we can express as a fraction of a over b. Let me give an example. Well, right here, root of 9, is a rational number because we can express this and write it as 3 over 1, right? Plus or minus, but let's say we want just a positive value, right? That'll be 3 over 1, because 3 over 1 is 3. But we see how we express this as a simple fraction as 3 over 1. Same can be said for root of 4. Root of 4 would be 2 over 1, and this is a fraction in its simplest form and cannot be divided or broken down any simpler. But these are not the only rational numbers, and I don't want to go too deep into this. We can deal with this some other time. But I just want to clarify that this is probably one reason it's a lot harder to compute root over 2, because it's a lot trickier to express it as a fraction. Now let's say I gave you a weirder looking square root, and I want to change the color up a little bit. So let's use a magenta color. And I said I gave you the root of 45. And I told you to compute this. Well, I already know that this is the same as 3 root 5. And you're probably wondering how the heck I know this. Well, you don't have to be a genius to know how to compute this. Well, because we're going to be introducing ourselves into a topic known as surds. And surds basically is a topic that deals with the manipulation of square roots. We learn how to play around with square roots. We can convert them from one form to another, learn how to multiply them, add them, subtract square roots. And if you decide to go onto your calculators and plug these two values in, you'll notice you get, if you put root 45 in your calculator, or some sort of book, or whatever, and you sort of want to find out what this value is exactly, you probably get 6.71 or 6.708, but I rounded it up. Yeah. And the same would be said for the 3 root 5, 6.71. And I'm just being honest here. You don't have to be one of those great minds that know how to you know, recite pi to the thousandth decimal place or anything to not compute this, because, well, I didn't even know what the decimal values were until I plugged it into the calculator. All I did was I just worked out the square root version of it. And we'll tend to introduce ourselves to things like multiplying root 3 times root 2 without having to break them down into their simple forms. We don't have, for example, if I gave you a, well, we don't have to write root 3 as a decimal and root 2 as a decimal and then compute it. We'll learn how to compute these kind of values. We'll learn how to divide them as well. Root 3 over root 2. And this is basically, I just wanted to give you a brief overview of what surds are. And I just wanted you to know what to expect in the following videos to come. So, basically, welcome to surds. Alright, see you soon.